In the previous video, we discussed the lab preparation of ethane gas, or also known as the acetylene gases. So today we're going to discuss here the chemical properties of alkyne or acetylene. So first of all, you must remember all the double bonds and triple bonds hydrocarbons, they undergo addition reaction, and alkenes undergo substitution reaction. So it's an addition reaction. So here I will explain you in such a way that you'll never forget the reactions by looking at the structures. Okay. So first one is your hydrogenation. Now what is the meaning of hydrogenation? Hydrogenation means addition of hydrogen. Okay. Then we have another reaction, addition of halogen. Now what are halogens? Chlorine, bromine, fluorine. These are your halogens. So addition of these halogens in your ethane is known as your halogenation also. Then we have reaction with hydrochloric acid. Now in halogen, fluorine is not used because it's explosive in nature. For that reason, fluorine is not used. So we are going to use chlorine or bromine, or we can even use iodine too. Now we are going to look at the first reaction. That is your addition reaction, or also known as your hydrogenation. Now the term in your textbook, in your ICSE book, you will find catalytic. The reason is the catalyst is used. So this is our structure of ethane. So I'm going to make ethane structure. This is our ethane structure, okay, with triple bond. Two carbons are there, so that's why it's eth. Triple bond means ene, ethane. Okay. Then we are going to add here, and we'll add here hydrogen. So what will be our overall reaction? So this is the reaction, also known as your catalytic hydrogenation. In ethane, hydrogen gas is passed over. So what is the catalyst used here? The catalyst is your nickel. So nickel is going to be the catalyst. Or if nickel is not available, even platinum or palladium is also used. So we are going to use your nickel. Now we are going to look at this reaction. Okay. Now this is the structure which I have broken down. It's the same. This is the reaction, and I've just broken it down. So I made the structure of ethane here. It's a triple bond here, and I broke this hydrogen into ions. So you have to remember the reactions in this way of organic chemistry. Now we are going to solve this. Okay. So here we have nickel present here. Now always remember, whenever there is a double bond or triple bond, addition reaction takes place. So addition means the bond here is going to break. Now the bond of this carbon, one of the bond is going to break. So I'm going to break this bond, the last one. So we have only double bond here. So what has happened here is the electron of this carbon is going to come back to this carbon here, and this electron will return to its carbon. So this is the bond is taking place. So our structure looks like this. So after breaking up the bond, I just place the electrons here. Now what will happen here is, now these hydrogens will form the bond here. So I'm going to put this hydrogen just below this carbon. Similarly, this hydrogen will go back here to this electron. So I'll place it here. Now we have a new structure. It's a double bond. So we call this, two carbons are there. So we call it eth. There's only double bond here. So we use ene, ethene. So this reaction is also used for conversion of ethane. That is a triple bond hydrocarbon, ethane to ethene. So this is our ethene. Now similarly, if you take this ethene, I have made the structure here, ethene, okay, with four hydrogens here, and if you add more hydrogens in them, now the bond, this double bond is going to break, and this electron will go back here, as well as this electron will go back here, and we have this hydrogen will form bond here, and this hydrogen will form a bond here. So our overall structure will look like this is how it looks. Now we have only single bond, and there are two carbons here, so we are going to write here eth, and it's only single bond, so we are going to write ene. So this reaction also can be used to convert ethane to ethane. First ethane is converted to ethene, okay, the bond will break here, then ethene can be converted to ethane. So this is known as your addition of hydrogen. So we have just added hydrogen here. So this is also known as a catalytic hydrogenation. Now we are going to look at the next reaction, also known as the addition of halogen. So halogenation. So we're going to look at that reaction. So here, for example, I have taken chlorine. So 2 chlorine. It's actually Cl2. So I have written 2. I have broken down this chlorine. So always remember, in organic chemistry, you have to do this. Okay, just to break this ions. Now in addition reaction, as I have told you, the bond between these carbon will break. So we are going to break the ions here, the electrons here. So it is going to break. So I've just used here. The moment it breaks, our new structure looks like this. This structure is this. Now chlorine is negatively charged, so it needs one electron. Chlorine has one electron here, carbon has one electron here, so they are going to form a covalent bond. So this is going to bond with this chlorine. So chlorine will come and takes place here, and this chlorine will come and form a bond here. Now what is the nomenclature of the structure? This is the IUPAC name. In the first position of this carbon, this chlorine is there. In the second position also there is a chlorine. So we have 1,2 dichloroethane. So this is how it is formed. Now this is your halogenation or addition of halogen. Now even you can add, if you want to add more chlorine now, let's assume that you're going to add more chlorine, Cl2. That means we are going to break this into Cl and Cl. If you're going to do this, there's a double bond. So double bond undergoes addition reaction. Further what will happen is, this one of the bonds will break, okay, and the electrons will be here. So I'm going to place chlorine, the previous structure, and hydrogens will be here, hydrogens present here. Now the bond which was here, these electrons, is placed back to this carbon. Now what will happen? Now this chlorine will come and form a bond here, and this chlorine will form a bond here. So all will have a single bond. So the IUPAC name here will be, in the first position we have two chlorines, okay, we have two chlorines, so we are going to write as 1,1, 2, 2 tetra. There are 4 chlorines here, 1, 2, 3, 4 chlorines. So we are going to write the IUPAC name as 1,1. First position we have 2 chlorines in the same carbon. Then 2, 2. In the second position we have 2 chlorines here. So altogether we have 4 chlorines. So we are going to write tetra, chloro, and the word root is here eth. So that is your ethane. So this is your addition of halogen. You can even do it with bromine. Now if you do it with bromine, you write here bromine and break the bond and place here bromine, and in place of this chlorine there will be bromine. You can even use iodine also for this reaction. And the last reaction is reaction with HCl. So this is our ethyne reacting with HCl. As mentioned earlier, whenever this triple bond addition reaction takes place, the moment you see this, actually in the reaction or in the examination, the formula will be given C2H2, okay, and we have HCl. Let's assume we have HCl. Then you have to solve the reaction. So it's a bit complicated. You want to remember, you can mug up. So what you need to do is, in a rough sketch or maybe at the bottom of this reaction, you make the structure more easy. So this is ethyne, and you break this HCl into H plus and Cl minus. Now the bond between this carbon and carbon, now this bond, which I'm showing you here, is going to break. Now once the moment it breaks, the electron will go back to its carbon, it will return to its parent atom here. Then our new structure will look like this. This is our new structure. Now hydrogen will be positively charged here. Okay. Now you are going to break this HCl into H plus and Cl minus. Now take this hydrogen and arrange it here, just below this electron of this carbon. Now chlorine is remaining. Now chlorine, take it and place it here. So this is how your reaction looks like. Now this is your structure. Now if you have to do the nomenclature, what is going to be the nomenclature here? Now look, there are 2 carbons here. So eth, word is going to be eth. But in the first position, there is chlorine. So we can use this term as chloro, and there is eth, 2 carbons here, and there is only double bond, so ethene. So this can be also written as chloroethene. So this is the reactions or the chemical properties of alkyne. Now this is addition reaction, okay, this is your catalytic hydrogenation. This is your ethyne is adding with hydrogen. What it forms, just a quick review, double bond, so it is your ethene. Now if you add more hydrogen in this ethene, and if you add more hydrogen, after adding more hydrogen in this ethene, we are going to form, now after adding hydrogen, methane, ethane is going to form 2 carbons and they will have a single bond. So you will find the reduction of bonds, triple bond, then double bond, and single bond. So this is the first reaction, and this is how it is written here, conversion. And this is the second reaction. Ethyne is reacting with chlorine. So here we have carbon, okay, it's not shown here. This is a bond, and this is a double bond, and we have 2 chlorines attached to it. Okay, now this is when chlorine reacts with it. The third reaction with its structure looks like this. Ethyne is reacting with hydrochloric acid. So if you find here blank, it's actually a carbon and a hydrogen bond, carbon-hydrogen bond, and there's a double bond here, and one hydrogen and one chlorine will form a bond together. So these are the chemical properties of alkyne.